Okay. So we begin with the next measures of dispersion. Okay. While central tendency refers to a value, okay, which represents the place where most observations are concentrated. Dispersion refers to the extent of which the values are diverse, or the extent of which the values are spread. So the spread of the observations, okay, is calculated by measures of dispersion. What do you mean by spread? In other words, if I have to calculate how much the data is far apart or how much the data is closely knit, how much is the deviation from the given values, okay, the extent of deviation or the extent of movement or volatility, whatever terms you use, this is represented by measure of dispersion. Whenever we speak of dispersion, there are four measures. What are the four measures of dispersion? Range, mean deviation, quartile deviation, and standard deviation. So how many measures of dispersion we have? We have four measures of dispersion. And these measures are called as the absolute measures of dispersion. These are called as the absolute measures of dispersion. We also have, for every absolute measure, we also have relative measure. It is not a separate measure. Every measure of dispersion will have a corresponding relative measure, which is represented by the term coefficient. Coefficient refers to the extent of relativity. Okay. So, range it is called as coefficient of range. This is coefficient of mean deviation. This is coefficient of quartile deviation. And for standard deviation, we use coefficient of variation. Okay, coefficient of variation. Now, when it comes to absolute versus relative measure, what is the difference? Okay, the first differentiating point for absolute measure versus relative measure. The first point is, this is actual deviation. So which means it will include the unit of measurement. If the question is in marks, answer is also in marks. If the question is in rainfall, answer is in rainfall, so on and so forth. So is in centimeters, whatever it is. Relative measure is measure of deviation with respect to central tendency. Deviation with respect to central tendency. Okay. Or I would say proportionate. So this will not have unit of measurement. Very, very important. Exam la 20 rupees 20. And example for say for example average income deviation 20 rupees 20 if you are doing relative measure, then rupees will not come. Rend option or exam la, you have to choose correctly. Relative measure will not have unit of measurement. Now, this is for calculating the deviation. Calculation of dispersion is done using absolute measure. Whereas, if I have two groups, A and B, I have calculated the dispersion, but I want to compare which group is better, which group has more deviation, less deviation, etc. Comparison is done using relative measure. Comparison is done only using relative measure. If you compare in absolute measure, you may end up getting the wrong answer sometimes. Okay, many times for that matter. So always remember comparison. If they ask A and B, which group has better consistency. Then we are doing a comparison. For comparison, which measure we will use? We will use relative measure. Okay? Clear with this? Okay? And remember the rule, whenever you are doing comparison, if dispersion is more, if dispersion is high, then consistency is low. Consistency is low. Similarly, if dispersion is high, deviation or volatility or risk all is high. So remember this question la vandu which is more consistent அப்படினு கேட்டாங்கன்னா whichever has the lesser deviation will be more consistent. Whereas if they ask which is more riskier, which has more deviation will be more riskier. So remember the relationship between each of these terms and the dispersion. Clear with these basics?
Yes, ma'am.
Can we go to the formula?
Yes, ma'am.
Yes. So we start with the first formula, which is the first measure, range. Okay. Range is nothing but the largest minus smallest value. Largest minus smallest value. Okay. Range is given as L minus S. So when I have, let's take an example. Again, for measures of dispersion also, like central tendency, we are going to learn the formula in three folds. Non-frequency, discrete frequency, continuous frequency. So, non-frequency, we say L minus S. Let's take an example. Now, what is the range here? Largest value 28 minus smallest value 10. Answer is 18. Same formula will apply when it is discrete frequency. No change in the formula because range does not consider frequency. Range ko frequency ko sambandhame kadayadu. Range only looks at the value spread. So range only considers the values and not their frequencies. Is again L minus S. So let's do another example. Now if you see here, the largest value is 19, which has only frequency 1. Smallest value is 10, which has frequency 3. Kavalaye kadayadu. In the frequency is not relevant. Range is nothing but 19 minus 10, which is 9. Okay, 19 minus 10, which is 9. Same way, example 3, if it is class intervals. Again, this is continuous frequency. What is the range? Same rule, frequency is irrelevant, range is L minus S. Now what is L? Largest value. What is the L here? What is L, friends? Ideally, we will say last interval order largest value or higher limit, which is 50. But here, the class intervals are not exhaustive. So, convert them into class boundaries. What are the class boundaries? 10.5 to 20.5, 20.5 to 30.5. 30.5 to 40.5 and 40.5 to 50.5. So the highest boundary will be 50.5 and yes, smallest boundary will be 10.5. So range is equal to 50.5 minus 10.5, which is
40.
Please don't do in this type of question. Range is 50 minus 11, 39. Pannadinga answer tappu because the intervals are non-exhaustive. Convert the intervals into exhaustive intervals, which is class boundaries, and take the highest limit from the highest interval and the lowest limit from the smallest interval or the first interval. Clear? So for range, frequency is irrelevant. So for under all the three methods, the formula is the same. This is with respect to range. Any doubts?
No, ma'am.
Now, coefficient of range is L minus S divided by L plus S. Now, you will get the answer in a decimal. So, to avoid decimals, we always represent coefficients of dispersion, or in other words, relative measures of dispersion in multiples of 100. So, technically, it is taken as a percentage. Okay, but you will see in most of your questions, this percentage symbol will not be there. But always remember, formula into 100 we will consider. Okay, it is L minus S into L plus S by, sorry, L minus S by L plus S into 100. Okay, this can also be written as L minus S divided by 2 into L plus divided by L plus S divided by 2 into 100. Now, what is this L plus S divided by 2?
Arithmetic.
Similar to arithmetic mean, but not exactly the same. Similar to arithmetic mean, but not exactly the same, because arithmetic mean will consider all the values and not just largest and smallest value. So, can I convert this into arithmetic mean? Is correct or tappa? Will it be right or wrong if I say this is arithmetic mean? This will be.
No, it will not be mean. It can be median potentially.
No, it will not be median also. Because median will again in between, depending on what your value is, only median will be considered. Median is positional, never numerical.
Okay.
Okay. Understood. So, remember, range can never be calculated directly using arithmetic mean, coefficient of range. So, please remember that you have to always resort to this formula. Or alternate, எப்போ use பண்ணலாம்னா, if they say, if it's given average of largest and smallest is. So they have themselves told that L plus S by 2 is what value. Ida kudutha mattu you can use the second formula, which is nothing but L minus S by 2 divided by L plus S by 2 into 100. When you can use? When they specifically give you the average of L and S, not average of observations. Average of L and S in kudutha da idha use panna mudiyum. Average of observations in kudutha idha use panna mudiyadhu. Remember it. Am I clear?
Yes, ma'am.
Okay. So this is about the first measure, which is range and its coefficient. Can we go to the second measure?
Yes, ma'am.
Mean deviation. What is the meaning of mean deviation? It represents the average of deviations from central tendency. But we already learned the term deviations from arithmetic mean is 0. So I cannot just use any deviation. I am going to use average or average, na, in other words, arithmetic mean of, this is the very important term, absolute deviations. Absolute deviations. Okay, average or arithmetic mean of absolute deviations. What is meant by absolute deviations? It is nothing but deviation. How to calculate deviation? X is the given value, each of the value, minus x bar. X minus x bar. So for every value, if the values are spread like this and you have a central tendency here, we are going to calculate the deviation for every value. So what we are going to do, every value is taken as x and we are going to take x bar, right? Absolute deviations means we are ignoring the sign. The deviation can be positive or negative because the values can be either less than arithmetic mean or more than arithmetic mean. So we are ignoring the sign. We are going to take only the value. So absolute deviation means sign is ignored. Only value taken. Now it is taken as average of or arithmetic mean of absolute deviations. So what will be the formula? Again, we learned the formula under 3 levels: non-frequency, discrete frequency, and continuous frequency. For non-frequency, again, first we will calculate x bar. Then do x minus x bar within the modulus, which means ignoring the sign. Now that deviations, we need to take the average. How to take the average? Total all the values divided by n. So sigma modulus of x minus x bar divided by n. Sigma modulus of x minus x bar divided by n. Okay. Now when it comes to discrete frequency, in arithmetic mean, what formula we did? Sigma fx by sigma f. So f will get multiplied. Same rule here. Sigma f into modulus of x minus x bar. Ma'am, should I take total of f and multiply with the total? No. Every individual value's frequency and deviation will be multiplied. I repeat, every individual value's frequency and deviation will be multiplied, divided by sigma f. N gets replaced by sigma f. Same formula when it comes to continuous. Sigma f into modulus of x minus x bar divided by sigma f, but x will be taken as the mid value. X will be taken as the mid value. Okay, f will be considered as the mid value. Right? So let's do examples on all the three for practice now. First example. Second example is discrete frequency. And third example, continuous frequency. I've just given numbers randomly, so you can calculate. Now remember, for everything, for calculating mean deviation, first what we need to calculate? We need to calculate the arithmetic mean. So calculate the arithmetic mean and we should do the mean deviation. Start. Yes, let's get to the answers. First one, 10, 11, 13, 17, 19, 20, 21. What is the answer you got? 13, 17, 19, 20.
Three point eight eight.
Okay. 17, 19, 20, 21. Correct? Yeah. Now, we need to, for what was x bar? X bar amounted to
15.86.
15.86. So 10 plus 11 plus 13 plus 17 plus 19 plus 21 divided by 15.86. So x minus 15.86 within the modulus. So 10 minus 15.86 minus 5.86, but we ignore the sign. Then this is 4.86, 2.86, 17 minus 15.86 is 1.14, 3.14, 4.14 and 5.14. Now you multiply this with f, we don't have f here, okay? So you get, take the total, (4.86) plus 2.86 plus 1.14 plus 4.14 plus 5.14. 27.14 divided by 7. So answer for mean deviation is equal to 3.88. Got it? Others were you able to find this answer?
Yes, ma'am.
Yes. Now same manner, when we do for the second question, 10, 13, let me do it separately, 10, 13, 14, 16, 18. Okay. 10, 13, 14, 16, 18. And what were the frequencies? 3, 2, 4, 3, 2. Okay. 3, 2, 4, 3, 2. Now first we need to find out x bar. Now for x bar for a frequency distribution, what formula we will use? Sigma fx by sigma f we need to use. So find fx 30, 26, 56, 48 and 36. 15. And what does this total to? 30 plus 26 plus 56 plus 48 plus 36. 196. So 196 by 14. 14. Correct? Huh? Did you get x bar as 14?
Yes, ma'am.
Had you done this 10 plus 13 plus 14 plus 16 plus 18 divided by 5, you will get 14.2, which is wrong. So you should not do sigma x by n for frequency distribution. It is always sigma fx by sigma f. Remember. Now we need to do x minus x bar, which is x minus 14 within modulus. So 10 minus 14 minus 4, but within modulus. So 4, 1, 0, 2, 4. Now f into modulus of x minus x bar. 4 into 3, 12. 2 into 1, 2. 0. 3 into 2, 6. And 4 into 2, 8. Total 14, 28. So mean deviation will be sigma modulus of x into x minus f into x minus x bar divided by sigma f, 28 by 14, which is 2. Got it, friends?
Yes, ma'am.
Were you able to do the third one? So third one, mid value is 15, 25, 35 and 45, which gives us, what is x bar? We need to take f into m, 60, 75, 70 and 45, totals 250. 250 by 4 plus 3, 7 plus 2, 9 plus 1, 10. So I think you will get x bar is 25, correct?
Yes, ma'am.
Yes. So now we do modulus of x minus x bar. I am doing it in this column, left side, just so that it's there in the same page. So x minus x bar modulus. So 25 minus mid value. So 25, 15 minus 25. So minus 10, ignore the sign. So 10, 0, 10 and 20. Now f into modulus of x minus x bar will be 10 into 4, 40, 0, 2 into 10, 20 and 1 into 20, 20. Taking the total 80. So mean deviation will be 80 divided by 10, which is 8. Did you get this answer?
Yes,
Yes,
ma'am.
ma'am.
Yes. So this is calculation of mean deviation under all the three formulae. Any doubts?
No, ma'am.
Good.
Ma'am, I have college at 11:45, ma'am.
Yeah,
Can
if
leave.
you can leave, yes.
Me too, ma'am.
Yes, those who have college can leave, not a problem.
Thank you, ma'am.
Thank you, ma'am.
Thank you. We'll continue. Yes. So now, coming back, before we go to the third one, coefficient of mean deviation is given as mean deviation divided by arithmetic mean into 100. Now remember, mean deviation is one measure of central tendency which we can calculate, okay, about mean, median or mode. So the question will tell you, calculate the mean deviation about median, about mode. அப்படி எதுவுமே கொடுக்கலனா mean is the usual that we will use. So what is, ma'am, will the formula change? Nothing will change. Instead of using x bar, you will use median or mode respectively if it is asked. Clear? Okay. So now if it is given this way, then your coefficient will be mean deviation by median if it is about median into 100, or it will be mean deviation by mode if it is about mode into 100. So depending on what measure you use, the denominator will change. This is the formula for coefficient of mean deviation. Is that clear?
Yes, ma'am.
Good. Next we have is quartile deviation. Quartile deviation. What is quartile deviation? Quartile deviation is the range or range between the two quartiles divided by 2, or otherwise called as semi-interquartile range. Why we divide it by 2? Because it covers not one quartile, it covers two quartiles. If you take the quartiles Q1, Q2 and Q3, the two extreme largest and smallest quartiles are Q3 and Q1, which actually covers two quartiles. But for deviation, we should only take one. We need only the deviation across a quartile on an average. So we will divide it by 2. So it is nothing but Q3 minus Q1 divided by 2. And how to calculate Q3 and Q1 we have learnt under measures of central tendency chapter. So I will not be repeating now. I hope that is clear. We have learnt it under measures of central tendency directly. You can refer that. Okay?
Okay, ma'am.
Right?
Yes, ma'am.
So now what is the coefficient of quartile deviation? It is Q3 minus Q1 by 2 divided by Q3 plus Q1 by 2 into 100. இது எப்படி எழுதலாம்? Q3 plus Q1 by 2 is nothing but median. So we can write it as quartile deviation divided by median into 100. Or you can also use how we use for range formula. Q3 minus Q1 by Q3 plus Q1 into. You can either use the first formula or the second formula depending on what data is available in the question. Deviation and median கொடுத்துட்டாங்கன்னா இந்த formula use பண்ணலாம். If they have given Q1 and Q3, you can use this formula. Is it clear?
Yes, ma'am.
Okay. Next. So this is about quartile deviation. Okay. Whether it is non-frequency, discrete frequency or continuous frequency, formula is the same. Calculation of quartile da marum, which we have learned previously. Okay. Now we come to the last measure, very important measure, standard deviation. What is the meaning of standard deviation? It is the average of squared deviations. It is taken based on squared deviations. Mean deviation is based on absolute deviations, whereas standard deviation is based on squared deviations. So here we are going to use x minus x bar the whole square. So let's learn the formula under each type. Non-frequency, discrete frequency and continuous frequency. Non-frequency, standard deviation is equal to mean deviation mariye da formula. Sigma x modulus of x minus x bar பதிலாக x minus x bar the whole square divided by n. But because we are squaring it, we need to bring the data to its original form. So we take the root. Now, this can also be expanded and written. So when you expand the squares mathematically, it will expand using the square value formula, square algorithms. So what happens? Algebraic formula, you will get sigma x square. Okay, so that expansion will come and it will simplify to this formula, root of sigma x square by n minus x bar the whole square. What is x bar? X bar is nothing but arithmetic mean. Okay, so depending on what information is available in the question, you can either use first formula or second formula. Am I clear?
Yes, ma'am.
Okay, next, discrete frequency. SD is equal to root of sigma f into x minus x bar the whole square divided by sigma f, or alternate sigma fx square by sigma f. அதாவது x square க்கு f multiply பண்ணணும் minus x bar the whole square. Same formula will apply for continuous frequency, but x will get replaced by mid values. Okay?
Okay.
Now, if they ask you the shortcut for SD of n natural numbers, examination question, root of n square minus 1 divided by 12. N square minus 1 by 12. This is the shortcut for SD of n natural numbers. Now, there is a term called variance. Remember, coefficient of variation வேற, variance வேற. Both are different. Now, what is this variance? Variance is equal to SD square. Variance is equal to SD square. Basically, same formula, root will get removed because we are squaring the value. Okay, variance is equal to SD square. Right, friends? Now, again, we are going to do a quick practice. Let me give you a couple of questions. You can solve it in any of the formula that you are comfortable with. This is example 1, example 2. I've just given random numbers. You can work out. Find the standard deviation. You can either use the first formula x minus x bar, or you can use sigma x square by n minus x bar the whole square. Either ways, x bar you need to first calculate. And remember, for standard deviation, x bar is always going to be considered, which means they will not be asking you to calculate standard deviation on median or mode. Standard deviation will never be considered on median or mode. It can be calculated only with central tendency of arithmetic mean. So standard deviation ki eppovume x bar arithmetic mean mattum dhaan. Okay, start working out. Yes, what is the answer for the first one? Same manner like how we did mean deviation is what you're going to work out. The only difference is that instead of taking modulus, we will be taking x minus x bar the whole square. Or you can use the alternate formula. X square, you can take just the square of the values divided by n. Okay, so what is the answer for the first one?
4.708.
Okay, which method did you use? The first x minus x bar or a sigma x square?
Sigma x square.
X square. That is easier to calculate because you just need to take the square of the values. 10 square plus 14 square plus 16 square plus 18 square plus 20 square plus 25 square. Divided by n, which is 1, 2, 3, 4, 5. No, 1, 2, 3, 4, 5, 6. Divided by 6. Minus x bar the whole square. So 4.708 is the standard deviation that he is giving me for the first one. Second one.
2.585.
2.585. And third.
3.0127.
So if it is continuous, again no big change, 10 to 12, 20, 20 to 30, 30 to 40, you will take the mid values and calculate. So I believe you can, you will be comfortable in working out the standard deviation. Any doubts?
No, ma'am.
Okay. So these are the answers that you would have got for standard deviation, right? So this, and variance of course is square of standard deviation. Yeah, okay. Now to coefficient of variation, which is equal to SD divided by arithmetic mean into 100. SD by AM into 100. SD by AM into 100. This is coefficient of variation. Okay, so with this we summarize the 4 measures of dispersion. Now let us go to the properties of measures of dispersion. Okay, properties of measures of dispersion. First, when all values are constant, the measure of dispersion is 0. So mean deviation, standard deviation, quartile deviation, range, everything will be 0. dispersion is equal to 0. Second, sigma, we learned this point, x minus x bar will always be take 0 from arithmetic mean. So which means sum of deviations from arithmetic mean is always equal to 0. Third, sum of absolute deviations. What is absolute deviations? Ignoring the sign, which means sigma modulus of x minus x bar is minimum when taken from median. When taken from median. Okay. Fourth point, change in origin and scale. Just give me a minute, friends.